A programmable logic controller is a digital device, which in essence means that it works on the concept of on and off. Now, when looking at the inputs, we know that we can connect switches, buttons, contacts onto a PLC. And we also know that the PLC will then use the information that it gets as a digital input. So if we have our switches and our buttons connected to our 24 volt rail, let's say this is a 24 volt PLC, these inputs are going to connect to the PLC which is also connected to that same power supply. Now this 24 volts is telling the PLC what constitutes on values and what constitutes off values. Now if we look at the scenario over here, I1 is connected to this normally open contact, which means it is receiving a 0 because it's not connected to the 24 volts. Input number 2 connects through the normally closed switch to the positive rail, and as a result it reads input 2 as a logic 1. Now as a logic device, PLC has the ability to serve as different functions or to do calculations in respect to what's happening on the input. Now looking at a ladder diagram, if we have multiple inputs, each one of these represents an input. I1, I2 for example, and that there is going to connect to an output device. That output device we're going to label Q, and Q will be my latch or the switch on the output side of the PLC. Now if I've got my two inputs connected like that in series with each other, then basically what happens is I have to have a connection on I1 and I2. In other words, these two buttons, I have to push both of them in order to turn the output on. If either one of those or both of those are open, then the output will be off. We call this an AND function. Okay. Symbol for the AND function to represent it mathematically, very simple. Let's call that input A and that one input B. And Q will then be equal to A times B. So we can see that Q will be on or a logic 1 if A and B are both logic 1s as well. To represent this as a truth table, A, B, Q, we've got 4 scenarios. We can have both off, we can have B on, we can have A on, or we can have both on. Now if both are open, Q is off. When I close B, A still keeps it off. If I close A, B still keeps it off. But if I close both, then the output switches on. To represent this in a functional block diagram, there's two methods, the American symbol and the IEC symbol. IEC symbol, very simple, shows the AND symbol with A and B on the inputs and Q on the output. And if we're looking at the American symbol, Q is on the output and A and B are on the inputs, like that. Now on a ladder diagram, as we've got over here, this would represent a rung. A rung is a step on a ladder. As this is a ladder diagram, this is one of the steps that is being taken. We're going to see many different types of logic gates in our proceedings, and we will then compare them and see how those different rungs work out to determine our logic functions.